Hello everybody, and welcome to exercise 3 on page 41 of the workbook. Let's take a minute just to read this problem together. So they're giving us a rectangular aquarium that has a length of 3 meters, a width of 2 meters, and a height of 2 meters. And it's filled to the top with a mixture of water and sediment. Then they go on to say that at a depth of y meters, the liquid in the tank has a density of rho of y equals 1,000 e to the 0.05 y kilograms per cubic meter. Okay, and they would like us to find the mass of the liquid in the tank. Okay, so just thinking about the problem big picture here for a minute. The density of the liquid in the tank changes depending on where we're at, and it's actually greater near the bottom of the tank. You can kind of think of it as the sediment is sort of maybe settling to the bottom. That's giving us greater density of our liquid at the bottom than at the top. Okay, and they've kind of got us started on the problem by already drawing a slice. I'm just kind of drawing the outline of it over here. Okay, and so I want to start by giving a name to the distance that you would get if you measured the distance from the slice to the top of the tank. Let's just say that that's y meters. Okay, and we're going to use the same strategy to find the mass of the liquid by starting just with the slice that we're looking at and asking, could we come up with an estimate of the mass of just that slice? Okay, well, we could start off finding the mass by writing down the density. Let's do that. So we've got a function for that that looks like 1,000 e to the 0.05 y. Okay, I'm going to include the units, kilograms per cubic meter. Okay, and my question to you is, if we start with units of kilograms per cubic meter, what units would we need to multiply by to get units of mass? Okay, well, what are units of mass, first of all? They're kilograms. Okay, so we need to multiply by something that's going to cancel the meters cubed out. Okay, so if we kind of put our units in here, we're going to get meters cubed. And what physical quantity is measured in cubic meters? Volume is. Okay, so the key here is what we need to multiply our density by is the volume of our slice. Okay, now there we need to think maybe a little bit. How do you find the volume of a slice that looks like this? Okay, think back to geometry for a minute. How do you find the volume of a rectangular prism? That's what we're really looking at here. Well, we've got 3 dimensions, length, width, and height. We just need to multiply those together. Okay, so if you think about the size of the aquarium, we've got a length of 3, that's this side down here, and a width of 2. So we'll take 3 times 2, and then what would the height of that little slice be? Okay, well, because it's very thin, it's customary to just call that height dy. So we're going to get 3 times 2 times dy meters cubed, and then notice that our units cancel, just like what we want. Okay, let's do a little simplifying here. We've got 1,000, and then we've got 3 times 2. If you multiply those all together, you're going to get 1,000 times 3 times 2 is 6,000, e to the 0.05 y, and then units of kilograms at the end. Okay, so there is the mass of just one slice of the liquid that's in the tank, and to get the total mass of the entire tank, we're just going to integrate, add up all of those slices. Okay, the only question left then is, what are the limits of integration? Okay, so ask yourself, what is the range of y values as we move from the top of the tank to the bottom? Well, in the problem, they tell us that the height is 2, and so that tells us the range of y values that we need. Okay, so we're going to get limits of integration from 0 to 2 in this case. Okay, and now we are ready to integrate, so let's see. 6,000 is a constant, and then we need to integrate e to the 0.05 y. Technically, we would need a u substitution there. Okay, I'm not going to write out the details of this, okay, but it would start out like that. You may be able to do this integral in your head by now. Okay, either way you do it, you're going to get an antiderivative that looks like e to the 0.05y over 0.05. That 0.05 in the denominator comes from actually doing the details of the u substitution. Then we're going to evaluate between 2 and 0. Okay, so let's see. If we just substitute our limits in here, upper limit is going to be 0.05 times 2 over 0.05. Okay, and oh, actually, you know, I'm going to do one thing to, I think this integral will be easier if we do a little consolidating here. Okay, you can do it however you want, but I'm going to take this 6,000 and divide it by 0.05, just to kind of separate the constants from the variables here. Okay, and 6,000 over 0.05, that ends up being kind of a big number. It's 120,000. Okay, and then I'm going to plug in the limits. Okay, by doing that, we can kind of factor the 120,000 out, and then just substitute in the limits to the e portion of this. Okay, so upper limit will plug in 2 for our y, and lower limit will plug in 0. Okay, so what do we get here? Well, 120,000. The thing to be, I'm going to show you what the answer is in a second here, but the thing to be careful of is that this is not equal to 0. E to the 0 is actually equal to 1, so don't forget about that second term when you're punching this into your calculator. If you do that, okay, substitute both of those terms in and see what you get, what you should come up with is this. Let's see. 12,620.5, and then the remaining question is, what should the units be? We are measuring a mass, and we can see from above that we got, after we kind of canceled our units, we're going to get units of kilograms here. Okay, and so that should be the mass of liquid in our tank.